So like I said, I'm going to get started. Introduction to Airflow. To start off, to kind of introduce everybody to the Airflow concepts, we're going to go through some slides, just help orient for the discussion. It's helpful if you know kind of what all the terms mean and sort of what all of the moving pieces are. We'll keep this section relatively short because we know everybody wants to actually get into the more meaty part. So I will go through a demo, kind of walk through the Airflow UI, how you actually build and define DAGs for data orchestration and things like that. It's part of the demo. But to start, kind of very basically, what actually is Apache Airflow? So Airflow is a tool for programmatically authoring, scheduling, and monitoring your data pipelines. For those that don't know, it was originally created at Airbnb and then was later open sourced and is now a top level Apache Software Foundation project. So I assume that everybody here has heard of Airflow before. It's pretty well known. It's become sort of a standard for data orchestration. And we at Astronomer are obviously heavily invested in open source Airflow. We think it's pretty great. There are a couple of kind of core principles for the Airflow that we think are sort of the, help make up the best parts of it. First is that, as you'll see kind of in detail as we go through, one of the core tenets of Airflow is that all of your pipelines are defined as Python code. So this means that you have kind of the power of Python behind you, and anything that you can do with Python, you can do with Airflow. So that's where a lot of that flexibility comes from. That's going to make it really easy to use for a huge array of different use cases. With that comes kind of a really robust community that has helped to develop, this network of Airflow integrations with other tools so that oftentimes you won't actually have to write a lot of Python yourself, but obviously it's there if you need it. So that's kind of that modular piece and the extensibility piece. In addition, Airflow is kind of infinitely scalable, which is obviously really important if it's going to be, a robust kind of enterprise grade orchestrator. Airflow was built to scale. And so, we at Astronomer have seen customers that are running like thousands and thousands of tasks every day. And Airflow, as long as you get it set up right, can handle all of that pretty easily. So lots of great stuff, lots of things to love. That being said, getting started with Airflow before you kind of know what all the moving pieces are can be a bit challenging. So that's why we're going to go through them here. I'll start with the core components of Airflow. So these are the things related to your Airflow infrastructure. They're going to be running underneath the scenes every time that you're using Airflow. So we won't go through these concepts in too much depth. You actually, if you're just kind of a new user to Airflow, don't need to know them too much. But again, it's helpful to know kind of what you actually have to get running in order for Airflow to be there ready for your data pipelines. So the three main components of Airflow are the web server, scheduler, and the metastore. So your web server is going to be a Flask server. It's running Unicorn. That's going to serve your Airflow UI. So we'll walk through that in depth. That's obviously an important piece. The scheduler is the daemon responsible for actually scheduling your jobs. Again, pretty important for an orchestrator. And then finally, the metastore is your back-end metadata database where all of your metadata are stored. So with Airflow, typically that's Postgres, but there are a couple of other databases that are supported. So those are the three components. We'll see those more kind of as we go throughout and talk about actually getting Airflow up and running. We also bring up the concepts of, or the components, I should say, of executor and worker here. So these aren't really core components per se, like the other three, but they are really important and it's good to know what they are and how they work. So the executor is going to define how your tasks actually get executed. And there's a couple of options with open source Airflow. They're sort of all good in different scenarios. We won't go through them too much in depth, just as part of the content for this. But if you do have questions about executors, you already know a little bit about them, feel free to raise those. And finally, you have workers. So those are your processes actually executing your tasks. So again, depending on how your Airflow infrastructure is set up, those might look a little different, but it's important to know that that's a piece that you will have to manage when running Airflow. So from there, we'll kind of dive into the core concepts that are going to be, sort of more top of mind if you're a data engineer actually, developing data pipelines in Airflow. And the most high level concept within Airflow is a DAG. A DAG stands for Directed Acyclic Graph. It is your data pipeline. So same, just a different name. Within that graph, you can think of, sort of each of your tasks as a node and each of your dependencies between those tasks as an edge. So something like the diagram here. The only rules for your DAG are that your tasks flow in one direction and have no loops. So that's the directed acyclic pieces. That means that, something like this simple example is totally valid. Something like this on the right is not, because you have this loop between T1 and T4. That could cause an infinite loop in your code, which is obviously bad. We don't want that. So Airflow will throw an error at you if you try to define something like that. But otherwise, you can define these DAGs however you want. They can have a single task, they could have thousands of tasks, kind of everything in between. And then drilling down one level deeper, the next concept is an operator. So operators are like the building blocks of Airflow. You can think of them as kind of like a wrapper around each task that's going to define the work that task actually does. There are a couple of different general types of operators to be aware of when working with Airflow. The first is going to be action operators. So those are operators that do a specific thing. So like the Python operator executes a Python function, or the bash operator executes a bash script. Transfer operators are similar, but they're going to be built out of the box to move data from one place to another. So like the S3 to Snowflake operator, for example. And finally, you have sensor operators, or more frequently known as sensors. Those are going to wait for something to happen. So there is an S3 sensor that will wait for a file to land in S3, or an external task sensor that will wait for a task in another DAG to get done. We won't go into too much depth on sensors today. Those are a bit more of an advanced concept, but we do have lots of resources on them. So if you have questions, if you think they might be good for your use case, again, just let us know. And then kind of, again, one level deeper from that, you actually have your tasks. So each task, again, is an instance of an operator. So remember, operators are like a wrapper around that task. So you might have, again, one task in your DAG, or you could have many. And then you have a task instance. So this is the concept that represents a specific run of that task. So you can think of that as like a DAG and a task and a point in time. So a specific task in your DAG might have many task instances over its lifetime as that DAG gets run multiple times. And then putting that all together, again, it kind of conceptually looks something like this. So you have, your tasks in your DAG. Each one is going to be wrapped by an operator that defines what is actually going to happen within that task. You can define your dependencies within your DAG. And again, all of this is going to happen in Python code, and we'll show some examples. The other concept I want to touch on here, kind of building off of that, is Airflow providers. And for anybody who may have already played around with Airflow or used it in the past, just note that the provider concept is referring, or I should say, is relevant to Airflow 2+. So most of this presentation is going to focus on Airflow 2+, although a lot of the concepts are relevant for historical Airflow versions as well. So provider packages are just Python packages, and they contain all of the relevant Airflow modules for a third-party service. So remember, I said each task is wrapped by an operator, and those operators define what is going to get done. But I also said that Airflow has this great community, so that in a lot of cases, you don't actually have to write the Python yourself. That's where provider packages are going to come in. So if you need your DAG to interact with, services on AWS or GCP or something like that, there's going to be operators that come already out of the box that you can install in your Airflow instance that are going to do that work for you. So that's a super great benefit of Airflow having such a robust and active community, is that there's been tons of development. So almost every data service out there that is frequently used is going to have a provider package, and we'll talk more about those as we go through as well. And then just to kind of bring that all together into a more real world example, like to show this diagram just to highlight that by using that network of provider packages and defining your pipelines in code, you can manage something really complicated like this with a lot of different services going on really easily with Airflow. And you know, when a new business requirement comes up and you have a new tool that you have to integrate, putting that into your data pipeline or your DAG with Airflow is as simple as adding a few lines of code. So this is an example of a real world implementation that we have seen. And again, Airflow manages all of that easily. So from there, I'm going to go ahead and hop over and talk a little bit about Airflow itself and kind of dive into a demo. I saw a question about, will there be a separate webinar on sensors? We have actually already done one. I think, Rocco, if you can find the link and throw that in the chat, awesome. We can send that over as well. But you can feel free to go watch the recording. Mark Lamberti did that. If anybody's familiar with him, he does all the intro to Airflow trainings and sort of Airflow famous, and he gave this really good webinar on sensors a few weeks back. So highly recommend checking that out. Cool. So I'm going to hop in and start with the Airflow UI. Kind of walk through what it looks like and how we can use it to interact with our data pipelines. I'll note here that I'm running Airflow just on my local computer. That's why you see localhost here in my browser. I will talk later about how to actually get this up and running and how we make changes when we dive into the code more. But for now, again, we'll start with the basics. Once you have Airflow running, this is what you're going to be looking at. I am running the most recent version of Airflow. So we're on 2.2.1 now. Super exciting. 2.2 had some great new features. So we'll throw that out there. If you're new to Airflow and you're just getting started, definitely use the most recent version. You're always going to have a better time in general, and again, get access to kind of latest and greatest features. So my home screen here is going to show me all of my DAGs that I have running in this Airflow environment. So I've got, whatever, 6 of them here. Obviously, a lot of them are turned off. So that's what you see here. Remember this when you're working with Airflow and you deploy DAGs. And then if you don't pay attention to this, they do get deployed paused by default. So remember to turn them on. This is a mistake that probably every Airflow user has made, is deploying their DAGs off and then wondering why they're not actually running. You do have to turn them on. If I go ahead and click into one of these DAGs, so we'll take this COVID data to S3 as an example, and I'm just going to walk through some of the most useful views here, give you a sense of kind of what's going on in the UI. I'm actually going to go to this graph view first, because I think this is really a helpful way of sort of getting a sense of what's happening with your DAGs. So obviously this is a graphical view. This one is, I find, particularly helpful, especially when developing DAGs, so that you can make sure that your task dependencies are defined in the way that you want them to be. So again, just showing that graph part of your DAG. The tree view is going to be similar. It's also going to show kind of statuses of your DAG, and it is laid out in a tree, so you do get a sense of the dependencies here as well. But importantly, this is going to show me, obviously, the statuses of all of my recent DAG runs. You can see these ones in green are successful. Obviously, we're color coded in here. These ones are red, failed, so something happened. Looking at the Airflow UI is a great way of, figuring out what's going on with your DAG. So if you got a notification that a DAG failed, you can come here, or you can see it here. And if I wanted to kind of dig into what's happening in this most recent run after I turned it on today failed, I can go ahead and see this is the task instance, obviously with my failed status. So it caused all downstream tasks to be skipped. That's why they have this orange status here. So if I click into this task instance, I have a bunch of options, one of which is viewing the logs. So I can go ahead and click on the log here, and this is going to show me all of the logs for this task. So this is going to be my best way of determining what actually happened, what caused the stag to fail. You will get logs for successful tasks too. Again, what they actually show depends a lot on what's going on in that task. But this is a great place to start. In this one in particular, I think that I tried to upload data into a table. Yeah, and the data did not match what the table was expecting. So Snowflake kicked it back and said, nope, you can't insert that data. So I would then, as the user, have to go fix this, figure out what was going on with the data. But Airflow makes it easy for me to see what's going on.
Hey, Kenton, there's a couple of discussions going on in the chats around, essentially you mentioned that DAGs are paused at creation. And I was thinking we can definitely dive into how you can set that at both an environment variable level, but also at the DAG definition level as well as part of the is paused at creation parameters.
Yeah, for sure. That is something that you can control. So that behavior where your DAG is paused by default when you deploy it, yeah, is something that you can change. In general, with Airflow, most settings like that you can change. Again, as Rocco said, some of them happen at the Airflow level. So when you're working with Airflow, you'll have what's called an Airflow config file where you set, global settings like that. Or you can always set them using environment variables. Some things will be at the DAG level, so you can change them on each individual DAG. And some things like that parameter can be both. So you can set them globally and then override them in the DAGs where you need to. So that particular parameter, not sure off the top of my head what it's called, but you can change that behavior so that the default is that they are unpaused. Yeah, good question. Cool. So for this DAG, I want to kind of dive in a little more to what the DAG is actually doing, and then take a look at the code. So you can see from the graph view that I have some parallel tasks happening here. I have this generate file, and those are color coded, so you can see those are Python operators. So I'm generating this file for a couple of different states. I then have this S3 to Snowflake operator here that's happening after, and then finally a Snowflake operator that is basically calling a stored procedure. So this is kind of a basic ETL sort of DAG. So what's happening within this one is I am grabbing data from an API endpoint for each of these states. I'm sticking that data into a table in Snowflake. And then I'm calling the Snowflake stored procedure that's actually doing some transformations for me. So this kind of is a good illustration of one of Airflow's best practices, which is Airflow is meant to be an orchestrator. It's not really a processing framework. So while I could process all of my data in Python just on whatever machines Airflow has available to it, that works well for small data sets, but it's not generally the most scalable option. So we're making use of tools like Snowflake that have a lot of built-in compute. And in this case, actually, I guess doing more of an ELT framework, which would be considered best practice. So looking at the actual code, in the Airflow UI, I have this code tab that'll show me the code that is powering each of these DAGs. I can't actually change the code here. So we'll go through in a minute how to actually where you would actually develop this. But this is helpful to just make sure that, the code is what you think it should be, or if you're just a user of Airflow and you don't have access to the DAG code, you can, go in here and find out what's going on with the DAG. So up front, I have a bunch of import statements. So again, all in Python here. Mostly what I'm doing is importing my Airflow functions and all of the operators that I'm using. So you can see that in some of these cases, Python operator is just built in with open source Airflow, but the rest of these you'll notice have this providers import path. Again, that's because of that providers package that I mentioned. So they are separate from the core of Airflow. and you have to install them within your Airflow instance. So importing all of my operators and a couple of other packages I need. For my upload to S3, I'm defining this Python function. I'm using a hook here. So hooks are a concept I haven't touched on before. They are kind of like a building block of operators. So hooks are usually just an abstraction on an API that allow you to connect to another service. So sometimes hooks actually have methods within them, like I'm using here. I have this load string method of this hook. So you can use them like this in Python functions, as opposed to just using an operator if the operator doesn't exist. But most operators are built on top of hooks. So you have them as a way to interact with external services as well. So here I define this function that uses this S3 hook to make a connection to my S3 bucket, grabs data from an API endpoint, it's just some COVID data, and then sticks it into a flat file on S3. Pretty simple. When I look down, well, actually, we'll come back to that function in just a second. Next, I can define any default arguments. So these are arguments that are used for all tasks in my DAG. The important ones I'll point out here are email on failure and retry. I have these turned off right now, but emailing notifications is probably the most basic notification function in Airflow. Super important if you don't want to have to go to the UI and look to see if something failed. Most people don't. They don't want to have to look at the UI all the time. So it's better to have Airflow tell you if something is going wrong. So you have lots of options available for that. The other important thing here is retries. So Airflow by default is not going to retry any of your tasks. If they fail, they fail, and then everything downstream will be skipped. But if you want your task to actually retry if it fails, which is good if you think your task might be dependent on an external system, maybe it hits an API endpoint that goes down, something like that, you can define how many times you want to retry those tags here, and also the amount of time in between each of those retries. Then I actually define my DAG itself. So this is super important. It's probably the most important part. This is going to tell Airflow that this Python file sitting in your environment is actually a DAG. So this is required for Airflow to register that DAG. I give it a name and a start date. That start date is super important. If you don't have a start date in your DAG, it won't be scheduled. So you could run it manually, but if you want it to actually run on a schedule, you have to define the start date. And I can define my schedule interval. So lots of different ways you can do this. You can use one of these preset things for simple schedules. You can use a cron expression. As of Airflow 2.2, you can define your own schedule. And that gets a little more complicated, so we won't go into that in detail here, more for advanced users, but you have a ton of flexibility on when you actually schedule your DAGs to run. And then the final parameter I'll point out here that's really important is catch up. So this by default is set to true for all DAGs unless you override it. Again, you can do that either globally or you can do it like I have in each individual DAG. If catch up is set to true, when I deploy my DAG and turn it on, Airflow is going to run any DAG run that would have been scheduled from the start date up until the current run. So if I deployed a DAG like this, that has a start date of June of 2020, and it's supposed to run daily. And if I deployed this today and turned it on with catch up equals true, I would run, almost 18 months worth of daily DAGs that would just start automatically. So that can obviously get you into a lot of trouble if you're not careful. Sometimes catch-up needs to be turned on for your use case. And we will have a guide actually coming out shortly that I'm working on now on sort of best practices and other things you can do to make sure you use catch-up safely. But just to note again, best to kind of leave it off unless you know you need it. So after I've defined my DAG, I go ahead and define all of my operators. So again, I'm using this snowflake operator was my last task to call a stored procedure. I can pass in the SQL here, or I could also, have another SQL file somewhere. And then these other tasks, remember I had a bunch in kind of parallel. I'm actually creating these dynamically within the DAG. So I'm looping through this set of endpoints that I define here. And to create one of these, Python operators that's going to call my Python function we went through up here, and one of these S3 to Snowflake operators, we're going to do that for each one of these endpoints. So again, because everything's just defined in Python, you have tons of options for, how you're defining your DAGs. And then finally, I am going to set my dependencies. So there's a couple of different ways you can do this in Airflow. Bit shift operators are my particular favorite. But this is just saying, kind of exactly what you would think. My start task has to come first, and then I go through this generate files, my Snowflake tasks, and then finally my stored procedure. So that's kind of a lot to go through. I know it can seem, a little, I guess, overwhelming at first if you're not used to Python, especially, or if you're not used to Airflow. But again, it doesn't take a ton of code to define, pretty complex pipelines. And once you get used to what the operators are and kind of how you pass in these configs, it will get easier. The other thing I want to point out is the astronomer registry. So again, we've talked about provider packages already. Those are those external packages used to interact with other systems. So unless you're doing everything like in Python operators or Bash operators, you're probably going to use provider packages. The astronomer registry is kind of the easiest place to discover provider packages. So obviously taking like AWS as an example here, this is going to show me all of the AWS operators, hooks, sensors, etc., that are available to me. This can be a really great place to come if you sort of know what your use case is, but you don't know if there's an operator available. Say I want, something related to like AWS Glue. If I search for Glue, it's going to show me, oh, there's actually Glue hooks and sensors and operators. I honestly don't know what these do, but if I click on them, I could find out. So highly recommend getting started here if, you're newer to the provider packages. The other great thing about the registry is that we have a ton of certified example DAGs on here. So you can obviously just browse these, or if you know what you're looking for, like some particular tool, you can look for it. So if I know that I want to have an Airflow DAG that's going to orchestrate some Databricks jobs for me, for example, I don't really want to write all the code myself, even using the provider packages. I want somebody to show me how to use those operators. I don't want to start from scratch. I can come here and search for Databricks. And you can see the section under DAGs here. There's an example Databricks DAG. So I can come here and it's going to show me all of the code. It'll also link me out to the GitHub repo where this is located if you wanted to just, fork that or pull everything down. But this is a great way to get started. So if I wanted to, add this DAG to my Airflow environment, I'll copy the code. But I'm going to shift gears and talk about kind of how to actually get Airflow running. So come over here. Again, I mentioned earlier that in this particular case, I'm just running Airflow on my local computer, which can be a great place to get started, especially if you're just playing around, if you're new to Airflow. The easiest way to run Airflow locally is using Astronomer's CLI. And it is free and open source, so you can go download it today, play around with it, and look at these example DAGs that we've gone over. It does require Docker to run in the background. So at Astronomer, we always run Airflow on Docker and deploy it onto Kubernetes. So, but that's the only prerequisite, although we you probably want Python installed as well, so you can actually write the DAGs. But once you have the Astronomer CLI installed, it's super easy to get Airflow up and running locally. You would just initialize an Astronomer project with astrodev init. I've already run that in this directory. That's going to create me a set of files and folders to run Airflow in a Dockerized setup. From there, to actually spin it up, I just do astrodev start. I've already done that as well. And actually, if I do a Docker PS, because we were just looking at Airflow, my computer a minute ago, you can see I have these 3 containers running. I have one for my, sorry, it's kind of, the wrapping is kind of hard to read here, but one for my web server, one for my scheduler, and Postgres is that metastore. So those were the 3 Airflow components that we talked about that are important for running Airflow. I have all of those running here. And that's how we were looking at the Airflow UI kind of on my local host just a minute ago. So once I have that up and running, the nice thing is that I can make any changes to my DAGs and they will show up automatically. So actually, before I copy that Databricks DAG in there, one thing I want to point out is, again, when I initialize that project, it's going to pull create a Docker file for me. This is going to pull one of Astronomer Airflow images. So same as open source Airflow functionally. You can choose what version you want to work with here. So again, I'm working with the most recent. Then my DAGs folder. So this is where Airflow is going to look for all of those DAGs. So you can see this COVID to Snowflake DAG here. This is exactly the same code we were just looking at in the UI. But this is where I'm actually defining it. So if I wanted to make a change to this DAG, I would come here and make that change here in the code, save the file, and then that should show up in my UI. So now that I've copied that Databricks example, I want to go ahead and say, add that DAG to my environment. Super easy. I can just add a Python file here. So I'll call this Databricks example.py. Go ahead and copy in the code from the Astronomer registry. And let's see where I'm defining this DAG. Example Databricks operator. I do have catch-up turned to false. That's good. So from here, obviously, this may not be the exact DAG that I need. Maybe I need other operators. This probably isn't the new cluster that everybody would run for their Databricks jobs, but you get the idea. I don't have to start from scratch writing that code. I understand how the operators, work, what I actually have to put in them, things like that. So again, great place to start. The other thing that I want to point out, sort of for basic Airflow usage, since most of your Airflow tasks, when you use them for data orchestration, are going to be connecting to external systems. So like Snowflake in the DAG we went over earlier, or S3 in that DAG, or Databricks in this one. So Airflow is going to need permission to actually connect to those services. So let's look at the COVID to Snowflake DAG as an example. So within these operators, you'll see a lot something called a connection ID. So like in the Snowflake operator, I have my Snowflake con ID, same in this S3 to Snowflake one, there's a Snowflake con ID parameter. Up here in my S3 hook, where I use that, I have an AWS con ID parameter. These are the connections that I store in Airflow that will connect to those systems. So this is telling Airflow, go look at this particular connection to get me the credentials I need to actually talk to S3 or Snowflake. So for beginners, the easiest way to actually add those connections is also in the Airflow UI. So come back to home screen here and look at admin. So under admin, I can go to connections here. And you can see I have those connections defined. So for the DAG we just looked at, I think it's this Astro S3 workshop one. Snowflake is Snowflake. Obviously, I have a couple of Azure ones set up for the other DAGs I have in this environment too. Taking a look at one of these, you can see there's a bunch of fields to fill out. So each of these will be different for it depending on the service that you're connecting to, but you can fill in all of the relevant connection information. So Snowflake actually requires kind of a lot of information. You have to give it like a database and a region, the warehouse and all that stuff. If I go back and look at this S3 one, this one's simpler. I'm just using an access key and token. So you can notice that the password is not showing here. It is actually in there. This is just Airflow's built-in security so that my password isn't showing on my screen. Anything put in a password field in one of these connections will also be obfuscated in any logs in Airflow. So you're all good there. There are other options for kind of managing secrets within Airflow, but again, if you're just getting started, I would recommend just defining the connections here. So that is that. Oh, perfect. And you can see that Airflow has picked up my new Databricks tag that I put in here. And it's interesting. It's not showing me the actual error, but Airflow will throw you an error here in the UI if there's a problem with your DAG file. This could be anything from like a syntax error in Python to this is being a little weird right now.
Hey, Kenton, could you just click on it with 2.2? I believe it was, there you go.
Oh, they're expanded. Thanks, Rocco.
Yes,
Sorry,
no
I'm
problem.
not even like super familiar with all the 2.2 features yet, apparently. They're just collapsed. How convenient. So this one is yelling at me because I don't have that Databricks provider installed in my Airflow environment. So if I hop back to my code with you can see in this Databricks example, I'm obviously importing this Databricks provider, but I haven't installed it. Again, those are separate Python packages. So Airflow says, I can't deal with this tag. Within an Airflow, an Astronomer Airflow project that I've initialized here, we have a requirements text file to add all of those Python requirements. So you can see here, I've added the other providers that I needed. I would just have to come and add the Databricks one here. And if I come back to the registry, you can see it actually tells me exactly what that import should be. So I could come back here, add it there. I would have to restart Airflow for that change to take effect. That's super easy from the Astronomer CLI. You just stop and start these containers. But instead of making you watch me do that, I do want to leave some time for Q&A while we have 15 more minutes. It's like I'm seeing lots of questions. So we just went through a lot of information in a pretty short period of time. So we'll pause there and yeah, take some questions. Rocco, do you have the Q&A pulled up? If you could read them to me.
I do, yes. Thanks, Kenton. Just pulling it up now.
Awesome.
So there was definitely some discussion when you had mentioned about how DAGs are paused at creation.
Yep.
So we had mentioned that there are some, available configurations both at an environment and a DAG level to do that. So we passed those in the chat. The other question that I thought was interesting was essentially Rajiv had brought up how utilizing connections within Airflow, and you definitely dove into that as well through the connections UI in the admin panel. So just checking out some of the questions here now. I see there is a question around cross-DAG dependencies, which I believe you were a part of that webinar, correct? And Chris, correct?
Yeah, so is the question on like, can you have cross-DAG dependencies?
Yeah, exactly. Like, how do you manage dependencies across DAGs? Is like, yeah.
Yeah, that's a really good question. The answer is yes, you absolutely can. There are multiple ways to do that. I will say we have an Airflow guide, which I'll actually, oops, sorry. Our astronomer guide site is also a great resource. This is all focused on open source airflow. So if you're just getting started, this can be a great place to look for sort of more detailed guidance on how to do various things in airflow. One of those, I wrote this one on cross-tag dependencies a while back. I will throw this in the chat to everybody. This will go through the different options for implementing dependencies across your DAGs. Short answer is it's a lot easier to do it if all of your DAGs are in the same airflow environment. And with that, you have a couple of different options from there's an operator to trigger a DAG. There's also a sensor you can use to wait for a task to be done. So kind of depending on how your DAGs are designed, those can be good in different cases. Yeah.
Thanks, Kenton. And I saw someone had put in the chat that those are great questions. Essentially, you know, there's using the S3 operator, but also the ability to use the S3 hook within a Python operator. And I think that plays into the ability to utilize Airflow with pipelines as code, that if there's a particular need for you to utilize the S3 hook within your Python operator, you have the ability to create that, right? And if you have a custom ETL flow, you can utilize and inherit some of those existing tools from those packages, or just use the underlying SDKs directly. So yeah, definitely, I've done that in the past. I imagine, Kenton, you've probably had some situations where the operator wasn't exactly what you needed, but you were able to utilize the underlying hook and connections of Airflow to implement your use case.
For sure. This kind of comes back to, you know, the flexibility of having everything defined in Python code is you can, again, and we would sort of recommend, you know, if something exists that works for your use case, use it, you know, don't reinvent the wheel and do your own. But if it doesn't, it's really easy to, you know, use hooks, existing hooks in a Python function that you define yourself. You can define custom operators or custom hooks that get reused throughout your Airflow environment. We see that a lot, especially if you're just making a small change to an existing operator. You can inherit the existing operator class and then make changes on top of it. So again, that's all like a little more advanced, but you have that flexibility available to you. So pretty much anything that you want to define, you can do that within your environment.
Thanks, Kenton. Yeah, and it's definitely a few times has been brought up around some documentation on how to, you know, get started with Airflow. I know you had covered that, but I think we'll definitely follow up and include, you know, links to our guides as well as our webinars. I know we publish a lot of material on getting started with Airflow, and then diving into some of these topics in particular in their own dedicated sessions.
Yeah, for sure.
Just checking through the questions now. So going back to DAG's dependencies, definitely, you know, I think someone had asked here, essentially, how can we think about cross-DAG dependencies across different deployments or different environments? And I think that goes back to what you had mentioned and what we were talking about in building customizations. And if there's a way to sense for or check for a certain dependency, you can do that, you know, utilizing Python, right? You can check if a file exists in a remote, you know, S3 bucket or in a GCS bucket or of that sort, and utilize that to, you know, create complex dependencies with outside resources.
Yeah, totally. Kind of related to that, I see a question on, can we define DAG dependencies within different Airflow deployments? The answer to that is also yes, but it's a little trickier. The easiest way to do that is using the Airflow API. And that guide that I linked in the chat also goes through that. So that's one option there. One thing I think would be helpful to cover, I see a question on, is it good practice to have multiple tasks within for loops within your DAG? Like I was showing in the example DAG earlier, I'm assuming was that what kind of prompted that question. The short answer to that is yes, it's totally fine. The somewhat longer answer is, again, remember that, airflow is parsing all of this code all the time with your DAGs to figure out like what's going on in them and what it has to do schedule wise. So you do want to be careful within your DAG files themselves to not have code that's so complex that it slows airflow down because airflow is going through all of that code. So a simple for loop like the one I defined there to kind of dynamically define tasks is totally fine. But as you get kind of more dynamic with your use case or a higher scale, that is something to watch out for.
I think another point on that too is how complex do you want your code to be in terms of handing that off to your colleagues and on-calls? I think there's definitely a balance to strike of how obfuscated the logic becomes versus taking advantage of the readability of Python and your pipeline.
Yeah, for sure. Some of it is definitely more of an art than a science once you get started. Cool. One question, can you build DAGs via the UI instead of in Python? The answer is no. You cannot actually define the DAGs within the UI. There's, they have to be defined in Python code. Unfortunately, that's again, kind of one of the core tenets of Airflow is that it's all Python. There's no like drag and drop. You can't make any changes to the code within the UI. Through any other questions?
Yeah, Eric had brought up utilizing the task flow API. And that is definitely, I'd say, a completely, valid way to build DAGs. And definitely, I'd say a lot of engineers are taking that approach in building their DAGs and transferring to the task flow API because it's a functional decorator based way of defining your DAGs and utilizing the inputs and outputs intuitively in your definition. So yeah, absolutely.
Yeah, great question. That's a great Airflow 2 feature that I should update the DAG that I showed, the COVID one, uses a Python operator without the task flow API, but I could totally change it. Yeah, good question. Also see a question about the cost of using Airflow. That's a really good question as you're getting started. Again, one with kind of a shorter and a longer answer. Shorter answer being that Airflow is open source, so it's totally free. Everything that you've seen me doing today, so including using the Astronomer CLI to get it up and running, and using Airflow, that's all no cost to you. Obviously, actually running Airflow like in production and using it might be a different story. So you're probably not going to want to run Airflow in production on your own computer like I'm running here. So there's resource costs associated with running Airflow that you would have to kind of keep in mind as you go through. And again, that comes down to a lot of like design and how you want to manage and scale within your organization. There are also companies out there that help organizations run and scale Airflow. Obviously, Astronomer being one of them. That is a service that we provide to our customers, which obviously comes at a cost, but then is less work for you to actually run Airflow. So I would say actual cost of implementation can vary greatly, but getting started and just playing around with it like we've been doing today is totally free.
Kenton, I saw a question come through, which essentially goes into concurrency controls and ensuring, essentially the question is there a way to control concurrent DAG runs? And essentially, there's different parameters such as, max active DAG runs. Using pools is another concept within Airflow where you can ensure that only a certain number of tasks across DAGs throughout your Airflow environment can run concurrently. So there's definitely a lot of configurations and controls at the task, DAG, and both Airflow level to control that concurrency, to match your let's say your database can only handle so many connections, or there's a certain load that you can only impose on it at a certain time, you can utilize Airflow to ensure that that's, held in check.
Yeah, for sure. That's kind of a rabbit hole of a question, or it can be. There's, doing that again at scale, there's a lot of different things to keep in mind. And as Rocco mentioned, you have a lot of different options available to you for controlling that. Which if you're just doing something like I showed here today and you have like 6 or 7 DAGs, you probably don't have to worry about any of that. But if you need to control for either, the resources available to you, like how many DAGs are running at one time versus like your task parallelism versus, I have a bunch of DAGs that hit an API endpoint and I don't want to overload that API. All of that is controllable using Airflow. We did have a couple of questions related to Astronomer specifically, and like what Astronomer does and like how we can help potential customers. Couple of things to just refer for those people. Definitely reach out to us. We would love to talk to you. One available resource for you that always happens is we have a weekly demo of the Astronomer platform. So talking about how that helps folks use Airflow weekly on Thursdays. We can probably find a link real quick to that from our website. Or you can always reach out using one of the contact forms on our website, or any of the webinar related correspondence, and we'd be happy to chat with you about any Astronomer related questions.
And Kenton, regarding the document, the recap will be provided, but is this code available for
Yes.
our audience to start with?
And that, yes, it is on GitHub. And that will be the link to that repo will be sent out as part of the recap. Yep.
Awesome. Yeah, I think definitely we at Astronomer have published, I know Kenton has contributed a lot to the guides and the webinars, and definitely there's a lot of content. Just quickly looking through most of the questions being answered, I can think of guides or webinars targeted directly around these subjects. So definitely I would encourage everyone to, take a look at some of the material available from Astronomer. You can likely find an in-depth guide from one of us discussing this particular topic and providing some samples around it as well.
Yeah, that's a great point. I've seen some other questions. I know we're running out of time, but about like if we'll have webinars on other topics, some of them we have already done. So all of the recordings from our past webinars are available on our website, in addition to the Airflow guides that Rocco and I talked about. The other thing, I know there was one final question about, just good resources to get started. Those are both great. The other thing I'll point out is our Airflow certifications. Again, Mark Lamberti, our resident Airflow celebrity, has developed those. They're super good. They come with a training course that you go through, and then you can actually get certified, which is a great sort of thing to put on your resume. We do have one that's on the sort of intro to Airflow side, and there's also a DAG writing one. So those, you can find those things on our website too. That would be a great place to get started as well. And I know there are, again, tons of more questions that we didn't get to. Love to see the engagement here, but we are out of time for today. So go ahead and again say that if the resources we mentioned don't answer your questions, or you just want to talk more about Airflow or Astronomer, like I said, feel free to reach out to us. I saw Eric put the link for that in the chat. Thanks so much. And yeah, thanks a bunch for joining us today, everybody. Had a lot of fun talking to you guys.